Yeah, hello and welcome to the session What's New in PTV Visum 2025 of this year's PTV Mobility Tech Update. Nice that you've made it and that you're interested in learning what Visum 2025 will offer for you. This session will not be the only opportunity for you to see what's new in PTV Visum. As you can see here, we've set up a whole series of more detailed deep dive sessions on particular topics, which you are also invited to join, most of them happening throughout November, and I will point you to the interesting ones during this presentation today. Today, I will try to just give you an overview on the most relevant new features. Shortly about me, my name is Arnd Vogel. I'm product manager for PTV Visum, working with PTV since very long and happy to present you some updates. So I will talk about a few things about the whole mobility tech suite and how Visum integrates with that, and also how it integrates with the new PTV cloud functions. We've got a whole bunch of new functionalities with regard to public transport and private transport procedures, and also our AVM functionality. And also, of course, as always, many bits and pieces for interfaces, tools, and usability, which we will look into. So let's get started. First, a little update on the mobility tech suite. As you can see here, all of the desktop products which you are familiar with, Visum, Visim, Viswalk, and Vistro, we are getting fresh new software icons. So from now on, you will see all those products appearing in the nice pink on your desktop, on your Windows desktop. And as you can see, this nicely integrates with the whole suite of products offered by PTV and Econolite under the label of Usability. So Visum, Visim, and Viswalk are here in the modeling and planning section of the Usability portfolio. Also, for all of the products, we have worked a little bit on giving you help. So the new products will integrate what we call Companion. It's an AI-based wizard or chatbot, where you can just ask your questions about the software, about features in your natural language, and it will give a short answer and also point you to relevant sections in the help or in other materials. So it has been trained on exactly those materials to keep hallucinations to the minimum. And therefore, you can't ask it general questions. It's not ChatGPT, but it's tailored to questions about Visum and how it's being used. Then a little bit about cloud connectivity, which is a big new upcoming topic for all PTV products. And let me first introduce PTV Hub, which is the new tool offered by PTV to support cloud-based transport modeling that will be released, I think, next week. So it's fresh on the market. This cloud offering extends the desktop products with additional cloud functionalities for managing licenses, for managing your models and scenarios, for providing dashboards, so to make the data accessible to other users, and also to organize all this data in workspaces and so on. Also for PTV Hub, there will be a dedicated session about that in November. So register for that and have a look what PTV Hub will offer you. For now, I will just give a very short overview how that integrates with Visum. So as that's an extension to Visum into the cloud, you find that, for instance, in the file menu where you can save your models into the PTV cloud, or of course, you can also open models from the PTV cloud when you're logged in. When you're working with a cloud-based model, all the changes you do to the model are tracked, and whenever you change something and upload the model again, you can set or write a comment about what you've done, because the cloud is all about collaboration, working together with multiple modelers, and therefore it's important to tell them what you've done to the model. So you can set up comments for your changes. And when you're in the cloud, so there's also a web-based cloud part to that, you see an overview on your model, and also here you can see a track of the versions which have been stored to the cloud along with the comments, so you know who has done what to the model. As you can see here on the top, in the cloud or in PTV Hub, scenario management is a very important topic. So all models support scenario management. You have the base network and you can define modifications and scenarios to that, very similar to what you are used to from Visum. So that's possible for all models. Even if you upload a simple version file in the cloud and in PTV Hub, you will be able to define scenarios for that. Of course, you can also upload your existing scenario management projects and they will be reflected in the cloud from there on. What's of course very nice, the cloud does not only offer scenario management, but as you can already see that here, you can also compute your models in the cloud. So you can run Visum, or you can run Visum models, but also simulate Visum models. You can run multiple scenarios in parallel, or in Visum also consecutively. So you you don't need to set up the computers for the computation, and you don't need to provide extra licenses just for computing the model. That's all offered by the PTV Hub cloud functionality. So you can keep your licenses for really doing the actual modeling work. And finally, what's a part of PTV Hub is dashboards. You may know that already as under the name of Visum Publisher. So that has now been merged into Hub as dashboards. And in particular for Visum, there's also extensions to the functionality. So now you can export your OD matrices or other relational data from Visum up into dashboards and visualize it there in to show, for instance, how the demand flows in your network are. So that's for now for the cloud functionality. As I said, you're invited to also follow the PTV Hub presentation, and there you will learn more about also the other functionalities. So let's start looking into new Visum features, and I will start with public transport. There's a lot of public transport features in there, and the biggest extension to that is a new functionality for automated public transport network design. So that's a tool which really generates new public transport lines and also suggests headways for them on the green field, as you can say. So when you don't have public transport defined in parts of your network, this will create or suggest new lines and also suggests headways for them. Use cases for that are, for instance, when you've got a new metro station being opened and you want to create a bus feeder network to that or adjust a bus feeder network. You've got new town quarters and want to connect them to public transport, or maybe more temporary situations when a section of rail gets closed down for a longer period due to construction and you need to create a substitution bus network around that area. Or maybe just if you have special demand or vacation periods and you want to adjust your network to that. So how does it work? You need to set up a few things. You need to define the infrastructure, which is basically the road network or the rail network with the actual travel times. You also define the possible terminal stations of lines there. Of course, you need to feed in the demand, which can be just public transport demand, but it could also be a mix of public transport demand and potential demand coming from car and other modes. And you can define what parts of the existing public transport shall remain fixed. So for instance, when you want the rail to remain fixed, of course, and you just want to create a bus feeder network. There's a few other inputs. So for your scenarios, you set up some things, for instance, like the available bus fleet and their capacities, or certain other settings about how well stops shall be served and so on. And very important is that you define your objective functions. So you frame how the network should look like. We will look into that later. And then what happens is that Visum in the back creates what we call a master network. So a very large set of possible lines, public transport lines, which could exist in your network, and then runs a genetic algorithm and a selection algorithm, which based on the objective function selects networks, line selections from this master network, which best fulfill your objection function. And at the end, it will not only generate the one best network which suits it all, but because we know that many networks can be similar and you are the experts to select the best solutions, it suggests a set of possible solutions consisting each of a number of lines and the suggested headways for the lines. And in addition, it creates a few extra solutions, as you could tell them, which are, for instance, suiting one part of the objective function best, so that you can look if I would optimize for a certain criteria, what would be the best network fulfilling that. So this objective function, this is really important to steer the possible solutions coming out of that procedure. So it's worth looking a bit more into that. You can see at the moment the objective function can be controlled by 8 different criteria. And you see that those criteria fall a bit into different areas. So there's a number of criteria which are suitable for optimizing a network for service quality for passengers. For instance, the actual travel times or the number of additional transfers. Of course, if you optimize for them, that's nice for the passengers. There's other criteria which better represent the operator perspective. So they manage to keep the required vehicle fleet to a minimum or to make sure that not too many empty trips are being done. And there's a set of criteria which are more from the administrative perspective, which, for instance, make sure that the whole network is covered, that all stops are served, and so on. And depending on your use case, you can weight those different components of the objective function by those factors, and thereby you can steer what solutions are generated from the procedure. And as said in the beginning, the procedure will not just generate the one best public transport network, but you see it's integrated with scenario management, and therefore it creates a set of possible solutions, each stored in a scenario along with the KPIs giving you information on how well a particular suggested network performs with regard to one part of the objective function. And then you can just open them and compare them. As you see here in this scenario, so this now starts and you sets up the parameters for the different components. You see here the weights of the objective function. When the procedure runs, it generates a whole new set of new scenarios, and you can open them and see what lines have been generated in this particular case. Here these are 7 lines, and you can select them, and you also see here's the attribute with the suggested headway for that line. For this very interesting new functionality, of course, there is a dedicated session on November the 13th. So if you're interested in that, don't miss that one. Another part of public transport where we've worked on is the import of ridership and ticketing data. So we have added actually a new data object here. So from now on, when you're working with ticketing data, you are no longer importing that directly into public transport paths, but there's now a new object type called ridership data, which is the target of the import. And from that, public transport paths and then further on skims and volumes and so on are generated in the regular process. Importing that data into a dedicated object type has many advantages. It's a better distinction between what's input and what's output. And by having that in a separate object, actually you can edit that data in lists or through COM. We can more easily attach other procedures for generating that data. So it's way better to handle for you. As you can see here in this example, here's a new list for this ridership data, and you can even edit that in Visum and change data or add new records and so on. Also for this functionality and other things associated with ridership data, there will be a deep dive session end of November. And finally, for public transport, there's an addition which is targeted to basic public transport demand modeling, and in particular, a little bit on how this is modeled usually in the US and some other countries, where transit is not modeled as a single system, but transit demand is split up into what's called submodes. So for instance, for metro or for commuter rail. So for each of these submodes, there's a dedicated part of the demand model and a dedicated matrix being generated. But in the assignment part, of course, all modes forming public transport can be used together. So even if you're looking just into metro, of course, feeder buses and bus connections can still be used. But the requirement is that in the assignment, when you're looking into metro demand, at least one leg of each journey must use the metro, so that it's really a metro-based assignment. This is now possible, also allowing other use cases like making sure that in other systems there's no transfers between operators serving parallel lines if they are competing and so on. And in Visum, this is controlled by defining specific subsets of the mode, which will then be enforced. You define them on the level of time profiles. You can define 2 of those sets for each assignment. And you can define if those subsets, if in the regular case, at least one leg must be part of one of those subsets, or if you are using 2, you can define how they are combined, if they're exclusive, or if both of these subsets must use. So you could even have something like just looking into parcels which are the combination of metro and bus and not direct metro connections, for instance. Okay, so moving on from public transport to private transport and some more general procedures. In private transport, an exciting addition to Visum is the emission calculation based on COPERT. So Visum has been able to calculate emissions based on HB-IFA for quite a long time already. But as you can see on the map, HB-IFA, the emission model, is mostly being used in some German-speaking countries and some other countries. So it's a little bit limited from the geographical scope. And now we've added COPERT as a second emissions model. COPERT is the standard emissions model used throughout the EU for calculating vehicle emissions. It's developed by a company called Emission, basically on behalf of the European Commission. So it's directly sponsored by the European Commission and of course, therefore also fulfills the relevant European guidelines. In Visum, we integrate the database being used by this COPERT emissions, the database of emission factors for warm and cold emissions, and also for the fleets of the European countries. And this provides all data needed to compute fuel consumption and emissions for various pollutants, CO2 for decarbonization, but also the other ones like NOx and so on, which are more relevant for air quality assessments. The emission is basically that, or the methodology is that those emission factors are provided for fine-grained vehicle stratums, and for each stratum, different factors depending on the speed being driven by the vehicles. Because the vehicle stratums are very fine-grained, they are composed into more aggregate things, and COPERT also provides data about how the fleets for different countries are set up, also for different years. And this is part of the database being provided with COPERT. And you basically select from that and associated that with demand segments in your the assignment model. And then from that, for each link, total emissions for the different pollutants and fuel consumption are calculated using the volumes and the speeds coming from the assignment. In addition to what was already possible with HB-IFA for the selected countries, there's an exciting extension that now you can even define your own vehicle types. So also for countries, for instance, outside the EU, if you know something about the emission factors for vehicles used in your country, you can now set up your own custom vehicle strata and their emission factors and use them along with the predefined ones in the computations. So looking briefly how this looks, what COPERT provides, you see here the vehicle strata, so very fine-grained types of vehicles with their fuel types and the emission standards they fulfill. From that, fleet compositions for the different countries are provided in COPERT, and for each of them, the emission factors for many different pollutants are provided. And in Visum, from this data, you create your fleet composition, as you can see here, maybe one for car, which shall be related to the car demand segment later on. From the COPERT database, you can say, okay, this consists of the car and light duty vehicles. You set up on which shares the different types have in your fleet composition, and then you associate this with the demand segments from your model, run the computation, and then you get the emissions based on the links, but of course from that you can also aggregate to other levels. And so that makes it very easy, for instance, to assess your scenarios, not only with regard to travel times, for instance, but also with regard to how well a project performs with regard to decarbonization, which is becoming a more and more relevant criteria, of course. Okay, also for that one, let me point out, there's, of course, a deep dive session introducing that in more detail and walking you through how to set up the model and run the relevant calculations. A more general feature, which is not only for private transport, but also for public transport, is what we call the balanced random condensing of matrices. The aim of that is to reduce runtimes of assignments, which is of course appreciated by everybody. And what often causes long runtimes of assignments is that matrices are often very highly populated and often populated with very small values for many OD relations, which is a result of how demand models work. They basically allocate demand to more or less every relation. And so what we want to do with this procedure is we want to remove the very small matrix values, but what we want to retain is basically the structure of demand. So for each zone, the rows, the totals, the row and column sums shall remain more or less the same. So if you are looking into how a typical matrix from a demand model looks like, you see here very small values like 0.01 and so on. So very small demand for certain relations. And after running the procedure, you see that those small values get eliminated and the corresponding demand gets allocated to other relations. And important is this new procedure works in a way that not only the total for the matrix is preserved, but also the marginals for the zones. So to and from totals for each zone basically get retained. So you're not losing demand, it's just distributed other ways and the very small values disappear. And this can be really very beneficial. We've here looked into quite a number of examples. Here's an example for an assignment of 7,000 zones, which went down from running about an hour to just 8 minutes. And if you're really looking into the assignment results, there's not a lot of information lost. The assignment results basically looks the same. So very helpful to reduce your assignment times. This is provided as a function, so you can integrate that in the procedure sequence and apply that to any matrix and produce a condensed matrix out of that. Then let's look into what's happening in the area of ABM. There's a few extensions to that. For instance, we've added the ability to doubly constraint the results of the ABM. A very common concept from aggregate models, where you usually run doubly constraint with regard to workplaces or school places, saying that the number of available workspaces in each zone shall not be accessed by what's being allocated as workers to them, or also that they shall be matched more or less, so that every workplace more or less is also consumed. In ABMs, this is rather complicated, so not many ABMs are able to offer that. But in Visum, we've now added this functionality so that you can doubly constrain, in particular, the work trips in the model, and workplaces are really consumed only to the degree that they are available. Second addition is we've added departure time choice as a new choice function in the model. The motivation for that is that nowadays you're often with your transport models not just looking into new infrastructure, but making better use of infrastructure. And that often means to better use infrastructure over time. Popular example for that is time-dependent road tolls, so that you in the peak hours you set up a toll and try to spread the peaks a little bit to make more people drive in off-peak times. And for that, of course, you need to be able to consider time in your choice model, and so also in ABM. So besides destination and mode choice, we now support departure time choice, which sets the departure time for the whole tour of the agents. This departure time choice, of course, needs to be restrained to certain restrictions, in particular to when people can work or when people can shop. You don't want people to shop at midnight if shops are not open at midnight in your area. And therefore, the procedure respects defined opening times for the activity locations, so that there's really control to how the times can be selected by the procedure. With this new type of choice, there's also the need to define where this is applied in the choice structure, and this is now possible. So you can define how your choice model is set up with regard to the levels of the different choices. So you can say first time choice and then destination choice, then mode choice, or the other way around. Or you can also, of course, leave out a certain choice. This depends on how people behave in your model. So the order of the choices is usually given by how important a certain choice type is for the people in your area, and of course to the type of the activity. This can be different. For ABM, we don't have just a single session looking into that, but we are planning to set up a session, a whole series of webinars in the next year throughout January. So that will not only look into these new features, but basically walk through the whole set of ABM functionalities and concepts available in Visum. So if you're interested in ABM, that will be a very good opportunity to learn what's possible there. Okay, then we will look a little bit into all the other additions made to Visum, at least a selection of this. With regard to input-output interfaces, we've added the support for GeoJSON as a format for input and output of data. That's it's not a new format, but it's becoming a very popular format for providing open data. And is in many places replacing shape files as the principal format to provide GIS-based geospatial data. And because it's from what it supports as a content very similar to shapefile, in Visum, it basically looks exactly like the shapefile import. So everything you can import from shapefile can now also be imported from GeoJSON, and the other way around. You can also export everything also to GeoJSON, which can be exported to shapefile. At the user interface, we've completely redesigned the user interface for flow bundles. There's not really a lot of functional extensions to that. It's just how the user interface works. So you have a better and clearer setup of the conditions. You can combine different types of conditions into flow bundles. So we call that partial flow bundles. So you can combine private transport flow bundle and public transport flow bundle into a single calculation. There's different conditions for the objects, so selecting a single link or selecting all active links. That's what you see here in this section. These are now clearly separated and have the associated buttons, and also additional parts of these conditions are now better indicated and easily accessible. And at the top, there's a few buttons which give you access to related functionalities very directly. What has changed a little bit is that in particular, public transport flow bundles should be much faster now. It's related to the topic of the ridership data. So in the background, we've changed how public transport paths are stored, which enabled the functionality for the ridership data as well. But this new redesign of the public transport data model also improves the computation time for flow bundles and other tools like the public transport path filter at the same time. So that's a nice side effect. With filters, there's a small but very handy addition that you now can define single filter conditions as active or not active. So when you've got only parts of your filter conditions changing or being relevant sometimes and some other times not, you don't need to define different filters and reload them, but you can just toggle individual parts of the condition by this new flag. And there's also new filters for the public transport for line blocks and block items, which lets you control which of those items are displayed in the line block view and so on. Also for public transport, there's a tiny addition, but it will also help to make your work more effective. There's a new attribute for public transport lines about the default color for these lines. It's actually something which is present in many places, that certain public transport lines always have a particular color. In particular, metro lines or rail lanes may have that. And therefore, it's also provided in many of the exchange formats. So for instance, GTFS carries on that information. And this is now included in the importers and exported in Visum. And we are currently working on making this new function, the new information available also as a default in all the graphical tools, so that it can be used in the graphic parameters automatically. That will be added in service packs during the year. Besides that, of course, as always, Visum is a large tool and we are working on many areas. So there's many further additions which we've done for instance, in the matrix aggregation, in the multimodal assignment, there's new options. We've done a few things in scenario management, which are streamlining the usage of that a little bit. So in particular, you will now be able to update all files used in scenario management to the most recent format. So you're maybe used that when you're opening a scenario management project with a newer version, the project gets converted, but all the other files like modifications and so on, they so far remained in the format which was used when they created it, and now this can be updated, so you get fewer warnings when opening certain files related to a scenario management project. That's only one of the other additions. As always, we include what's new document with the software, and with the basic release and all the service packs, you will get release notes informing you about all the other changes. So you're always welcome to look into that, and we will always be open to answer your questions and support you. And with that, I will just again point you out to the upcoming sessions on Visum. Yeah, we would be happy to see you there and give you more insights into the amazing new functionalities.